Hi, I'm Doug Black. I'm editor-in-chief at Inside HPC. And today we're talking with Shahin Khan. He is founding partner and analyst at OrionX.net, which is an industry analyst, market execution, and demand generation consulting firm in Silicon Valley. Shahin, welcome.
Thank you very much. Glad to be here, Doug.
Great to be with you. I understand that in the big picture realm of IT strategy, including HPC and advanced computing workloads. Your sense is that edge computing is on the ascendant this year. Why is that?
That's absolutely right. We do think that edge computing is poised to be the next phase of IT. And if you put it in that context, then you can think of it as a pendulum that's moving from central kind of focus to distributed focus, back to central, and now back to distributed. So we started with mainframe computing, then that led to client-server computing, that led to cloud computing, and we think edge computing is now client-server 2.0, just like cloud computing was mainframe 2.0. Now, of course, the HPC community had a pretty big role to play in the evolution of cloud computing, initially with grid computing and everything that the supercomputing world did to try to make that happen. So likewise, I expect HPC and AI to play a significant role in edge computing.
Okay. Now, we spoke recently, and I know that you kind of look through things big picture wise through the prism of AI, HPC enabling AI processing,
Mm-hmm.
IoT, uh, cyber currencies,
That's
and,
right.
and 5G. So within the realm of, I guess this would go in the processing end of things, HPC, but also the notion of AI everywhere.
That's a great way to put it, actually. Yes, I mean fundamentally, as you know, you helped us clarify it and say it as well as I think we do now. But IoT is the fountain of data. 5G is probably how it's going to get communicated. It's going to get communicated many different ways, but 5G leads the way there. AI and HPC is how it's going to be made sense of. Cryptocurrencies is how value is going to be assigned and moved. Blockchain is how it's going to get transacted. It's kind of new ways of transaction processing. Quantum computing is an example of how it's going to get accelerated. And of course, we have kind of quantum, classical, digital, analog, and those 2x2s are starting to interact with each other. And then, of course, you have things like cybersecurity that cuts across the whole thing. So edge computing is really the totality of all of that, is to recognize that IoT and 5G and AI and all of these are creating a universe that goes from devices to the cloud and back and everything in between. Now, back to your initial question of why is that? The short answer is too much data. If you didn't have too much data, you could have a device on one end, cloud at the other end, and you'd be done. And in fact, in the early days of cloud, we called it mobile cloud, and it was like terminal mainframe, mobile cloud, and we're good. But now that space in the middle is getting filled up. There's now base stations and edge data centers and regional data centers and actual enterprise data centers that are sitting in between the device and the cloud.
Right, and just so much data being generated everywhere. You know, when I think of it, if you have these three big camps in IT, if you will, cloud core, meaning the on-prem data center, and then you have these edge data centers. Do you think maybe the diminishing player of the three of these three might be the on-prem data center, or am I off base there?
I actually think this is helping all of the above. It's just that they need to be cooperative. None of them is an end-all, be-all. And there was a time when cloud looked like it was going to be that, and that's not happening. So the reality is that most of the data is going to be generated and ultimately consumed outside of the cloud. So edge computing now highlights that, and it requires that the whole cooperation of processing, storage, communication happen across the fabric. So it is exposing the fabric as a potentially new platform with a potentially new computational paradigm that will govern it. Now, that is really a very complicated world because you now have embedded computing for sensors and microcontrollers. You've got mobile computing with mobile devices and whatever else that might be, not in one location fixed. And then you got cloud computing. And these are very different disciplines that you need to bring under one umbrella. And then you add cryptocurrencies and blockchain and other sorts of new peer-to-peer Lambda and serverless and containers, and suddenly the entire situation becomes simultaneously very exciting because you're now putting it all in one place, but also really complicated.
Yeah, yeah. The other day when we were talking, you mentioned that the car, for example, the autonomous car, how much data it's generating each day, and then what do you do with it? Some of it has to be processed immediately. A deer runs into the middle of the road in front of the car, or you offload that data almost manually. Isn't that the case?
Yeah, absolutely. Again, this goes back to too much data. If you have too much data, that you can't even store it, so you have to reduce it even as it comes in. If you have too much data to make sense of it, then you need algorithms and AI to make sense of it. If you have too much data to send, then you have to decide how much of it to hold locally and how much of it to ship across. And the equation is going to be different for different use cases. So in an autonomous vehicle kind of a scenario, you may be generating 5 terabytes per hour. And you're not even going to, now the car is parked outside when it comes back from its kind of data gathering. It's probably easier to just have removable drives that you just lift out of the trunk of the car and walk into the building and insert into a server. That's pretty high bandwidth. So SneakerNet beats any other solution right now. So in the parlance, they call it multimodal data transfer because it's just easier to physically move the medium. But once it gets there, then you're not going to send it all across the network because you may not even need all that data once you get to the other side. So you can do federated learning. You have to do conditioning, filtering, uh, cleansing, reformatting. You need to do a whole bunch of metadata so you know where the data came from, what specific car, what time of the day. And then you need to keep track of all that data as you generate an AI model so that if something goes wrong, you know what vehicle did it come from, what particular scene did it come from, what time of day did it come from, so you can root cause it. And then the whole thing is needed for compliance purposes so that you know where it came from and how it happened. So all of that has to happen. And a bunch of that is relatively computationally intensive. So you may as well do it locally and do it through HPC algorithms and AI algorithms. And that's what we are observing now.
So some of the key enabling technologies that's supporting this notion that this is the year kind of idea, and not to box you into this 12 months, but that edge is really coming to the fore. I guess it would be certainly increasingly powerful processing CPUs, but also, of course, GPUs, and then ARM and FPGAs, where they can play, but also some of these data migration technologies. Is that the case?
Yeah, absolutely. So when there is too much data, every technology that touches data at scale becomes interesting. So processing at scale requires accelerator technologies, GPUs, FPGAs, vector instructions. Now, some of these are going all the way down to the microcontroller, where they need to operate in a very tiny space, but they still need to be able to perform some tasks that are fundamentally HPC in nature. So they may not be exascale, but they're HPC. They're high density processing, as we call them. And that could be encryption, it could be data reduction, it could be image processing. If you have lots and lots of data coming in and you've got image processing algorithms that are really good at what they do, sometimes it makes sense to pretend that what you're getting is actually an image, even if it isn't. You just have a 2x2 matrix and you say, you know what, I'm just going to pretend that's an image because I've got a hammer and this looks like a nail. and I'm going to push it through, and suddenly I get insights that I couldn't get through traditional means. So we are seeing some of that as well. Now, then you move up the ranks, and then you get these edge devices that are very powerful. Some of them have multiples of GPUs on them and multiples of CPUs on them and lots of memory, but then also maybe not, depending on where things go. The environmentals becomes important. So if you have a mini supercomputer sort of a thing sitting at a base station, what happens when it gets too cold? What happens when it gets too hot? Does it, what happens when humidity goes up? So you have to kind of figure all of that out. And then it goes ultimately to some local data center or to a regional or to a main local data center on its way to cloud. But as it goes towards the cloud, data gets reduced and reduced and reduced so that storing, processing, or shipping it becomes cheaper and more tractable. Now, once it gets to the cloud, it tends to accumulate. So cloud, even though a lot of the data doesn't get generated inside of the cloud, it does get accumulated inside of the cloud. So that kind of leads to data gravity. And then what we're observing, as we were talking earlier, is that edge computing is achieving escape velocity out of that gravity by saying that, some of this data really needs to be outside of the cloud, and we need to store it and communicate it and process it there.
Yeah. Now, this larger framework that you've talked about, those 5 key technologies, and then this edge core cloud, that seems to be a framework that'll carry us for a long time, right? And if edge also includes the handheld device, the phone, whatever it might be, I mean, that seems to have a lot of legs to it, doesn't it?
I believe it does. Now, as you mentioned, there are different kinds of edges. We define 3 classes of edge. We basically say the far edge, which is the tiny devices, mobile devices, handsets, and things like that. The near edge, which are the thicker devices, more hefty devices that could themselves be pretty substantial. And then you have the mobile edge, where it is like essentially a mobile phone or a mobile car or something that's not geographically fixed. So those define the 3 kinds of edges, and then they all cooperatively work with the cloud and with the core, as you mentioned. Now, what you might say, well, what is not included in that umbrella? What is not included directly is really the bioinformatics aspect of things, is the biologically based organisms and computing that may come about at some point. Those are still at their infancy, so that's not quite covered. And the digitized version of them is already part of the IT infrastructure. And then robotics is essentially the combination of AI and IoT, the way we see it.
Great. Shahin, tell us a little bit about OrionX. Refresh us on the firm and its sort of vision and mission, if you will, where it fits into the consulting analyst ecosystem.
Right. So, when we were, the company has been around for now over 11 years. Time flies just like that.
Mm-hmm.
When we got started, our focus was specifically on being a marketing agency. So we acted as interim CMOs and interim CXOs and did specifically marketing activities. Over time, we have moved upstream to be a technology analyst firm, and our focus is digital transformation, and the 5 or 6 items you mentioned are under that umbrella. And then we also went downstream to work on demand generation and customer engagement. It's a very small firm, but our focus is on super high quality, a little bit selective, and be able to add value and partner with our clients, essentially make friends with them because life is too short otherwise, and continue to learn, which is what we do. And those who've really interacted with us hopefully have seen that sort of a culture come from us, which is, know what you're talking about, go deep and go broad. Now, part of that strategy and vision was because we are based in Silicon Valley, and we necessarily worked with a bunch of startups. So we had a bit of a early visibility to the trends, right? So we were doing cloud computing before it became a thing. We were doing big data, we were doing AI, and of course, edge computing. We've been seeing edge computing for the past 2-3 years now, and it's been brewing. So, part of the reason why this year is because we think the confluence of, like you said, infrastructure, algorithm, data, viable economic use cases, those are all coming together to give it the escape velocity that we talked about.
Great, great. All right, Shahin, very interesting. Thanks for the discussion, and thanks for spending time with us.
My pleasure. Thank you so much.